Hello, good morning, good afternoon, depending on where you're at. Thank you for joining TriStar's webcast today. My name is Steve Schroeder. I will be your presenter for the next 45 minutes to an hour. And today we're going to be talking about CAD automation with PLM integration. Specifically, we're going to be exploring different ways companies can efficiently implement CAD automation in a PLM controlled environment. So I'll be going over a bit of an overview presentation, then we'll jump into a live demonstration. We have a moderator that'll be helping us out today and can be looking for questions in the chat if you have those questions, and I will try and answer those at the end. So just a little bit in the way of introductions. Again, my name is Steve Schroeder. I'm a business development manager with TriStar. So my role at TriStar has been helping companies implement PTC's Windchill PLM product line and Creo CAD tool and try and gain the most value out of those tools. If you're not familiar with TriStar, TriStar is one of PTC's largest partners. We are headquartered in Phoenix, Arizona, and have been around since 1988. So TriStar has a large services organization. We also resell the PTC software, and we help companies implement Windchill PLM and Creo through consulting services and training services. We have over 1,400 Windchill implementations that we've been involved with a wide variety of companies that range from fairly small companies with maybe just a few mechanical engineers using Creo, all the way up to very large global companies that are implementing Windchill PLM throughout their organization. So let's start out this presentation by talking about the problem statement that we'll be addressing. We work with a lot of different companies. TriStar works with a lot of different companies that develop configure to order and engineer to order products. So products that are very similar but might change slightly per order depending on a customer's requirements. And these products can vary in application, anywhere from a custom electronics rack with custom electronic equipment to high-tech products to electrical transformers that you can see in the center of the screen here, to actually ventilation systems for industrial kitchens, even to more kind of basic products around custom file cabinets and desks. So there's a lot of variation between these configure to order and engineer to order products, but the goals are usually the same. It is trying to enable their engineers to be able to rapidly design or rapidly create new configurations in CAD and manage these configurations in PLM. So traditionally, if you look at the Creo product line specifically, and even back to the old Pro Engineer days, you will have a variety of tools that you can use in Creo to build out CAD automation. These include simple parametric relations that you can build within an assembly or within a part. Family tables are widely used, allowing you to develop a table with dimensional values in there, or even features or components that you can turn on or off. Pro Program is a very common tool that has a scripting language allowing you to also develop relationships, but in addition to that, be able to drive logic for which components or features to turn on and off. Notebooks or layouts are also commonly used. This is a specific file type within Creo, a 2D environment that you can see a snapshot here where you could build out global parameters. You can define common assembly constraints like datum planes or coordinate systems or axes, and you can use that to drive multiple models. And there's other tools as well, like user-defined features where we can group components or we can group part level features together to be able to rapidly add that geometry into our models. Interchange groups can also be used in Toolkit. So there's a lot of different tools that companies have been using for quite some time to build out CAD automation. But there's some issues with these tools. And the issues, there's a variety of them, but some of the key issues that come up are using these tools in a Windchill environment. I'm going to be exploring this quite a bit more in the next few slides and in our presentation. Beyond that, just generating new configurations. How do I go from a template model that has all these relationships and a program tied to it to building out a new customer-specific order in an efficient way? Configuration management can be an issue. How do I understand if I've built a very similar product before that I could utilize, or maybe the exact product, or how do I limit part level duplication if I've generated a component with the same geometric definition? Modular automation is also an issue. So if I wanted to set up automation at a sub-assembly level or a modular level, maybe develop some automation around a frame for my design, and then use that new subsystem, module, or sub-assembly at a new top-level assembly, how can I efficiently do that? And then last but not least, actually, is building out a customized user interface. A lot of companies are using all these different tools in conjunction with each other. And if you're not an expert user, you haven't had experience walking through the configuration process using a notebook, perhaps pulling up an assembly and regenerating and going through this process, it can be a little bit overwhelming depending on your product. So how can we build out a user interface that is efficient, can drive a individual through the configuration process with logic, and potentially be used by a non-expert user or even a non-Creo user? So these are some of the issues that at TriStar we've been working through. We want to be able to leverage these existing tools, but we also want to be able to solve these different issues that historically have arisen when using these traditional Creo automation tools. And the first issue I'm going to kind of outline a little bit further is what I call the reference problem. Now, if we go out and develop a notebook, I'm assuming many of you in the audience are expert Creo users and probably done this before. A notebook is a great way to collect global parameters. So values for different components that could be used. I can even develop global relations between these parameters. I can develop global placement constraints, as I mentioned, and then I can declare a variety of models back to this notebook. And this is important. Maybe I have a length value that I want to declare into multiple components. Maybe there's some information about placement that I want to push into different assemblies. But ultimately, we're developing a reference link back to this layout through a variety of models through that declaration process. Now, many companies that are using the notebook and declaring a layout through an assembly will then pass that information into program. So we might pass information about which components are going to be utilized based on some relations or input values in the notebook. And the program then we can simply regenerate, and that will build out a specific assembly from the information in the notebook. And this, again, can resume or suppress components. It can also swap out components through component interchange. And so we have some more information that is being related together because we're passing relations and parameters from the notebook now through the assembly into the assembly's program. And further, if we wanted to enable interchangeability between components within our assembly, we could do that in a couple different ways. The first way to do that, in a very common way, would be to enable a family table. So maybe a certain component or even an assembly, we could build out a table here with parameter values to change, the length of a component, the size of a component, whether or not certain features are on and off in a particular component. And each row within this table then would become a different part number. And because it is a family table within the Creo environment, Creo understands all its assembly constraints, and therefore we can swap this component out automatically in an assembly or even manually through the user interface. But often in this example, we would talk about a notebook passing in a part value and then replacing that component. If a family table is not realistic and you still want to swap out interchangeability, perhaps maybe there's a subassembly that could be replaced by a single part, then you'd have to go through another method. And that typically is solved, that issue I just described, through an interchange assembly. In this case, this is another file within the Creo environment, another assembly type. that you can utilize. They're pretty easy to make. You can just go in and drop components in, and you say, hey, this datum plane of this subassembly or this part is the same as another one. Similarly with the axes or surfaces, and what that is doing reference mapping within the Creo environment, and therefore I could take, a individual component with a assembly, for an example, map like references and be able to swap these parts in and out. Now, this type of infrastructure has worked well, and companies have been using this for quite some time. But as I mentioned earlier, there's some issues with this. One of them being just the complexity of this reference chain and being able to track this all down and understand how we can utilize these whole tools. The second issue really is about assembly size. So oftentimes when companies are using these techniques, they will have a series of components or subassemblies that are suppressed within a large top-level assembly structure. So those might be subassemblies, as I can see by the black dot here, or individual parts, or maybe some parts in a pattern. But ultimately, companies are building up a large super assembly, if you will, where the program and the relationships are suppressing and resuming these components, and that ultimately is resulting in very large assembly structures. And that can be okay, because of course these parts are suppressed so that, that's not really taking a memory footprint as you bring it up into Creo. But it does present some issues. One issue that does occur is that when you have these very large assembly structures, this can lead to a very complicated or lengthy program. If you've ever dealt with program, you will notice there is a relations section and then there's a component section. And in essence, Creo is listing out every component in the assembly structure, whether it's suppressed or not. And you can control through the scripting how you resume them or suppress these other components. But ultimately, every component in your assembly structure is going to be in that program listing, and therefore you're going to end up with a lengthy program that you're going to need to control. And the second issue, and one of the key things I want to talk about today, is how this reference structure and these large assembly structures, what impact that has on the Windchill environment. Now, of course, as you might hope and you might expect, is that the relationships that are being created as you build out these family tables and these interchange groups and these references to a notebook are all understood within the Windchill environment. That should be part of your PDM function, but this is actually both an advantage and a disadvantage. Really, the problem occurs, and one of the key issues we're going to talk about today is how you generate a new configuration in this environment. So let's assume that we're building out a template model, very common for a company to do this. They'll have their base, I'll call it super assembly, generated with all this logic going on with family tables and interchange groups and this notebook, and they've got it checked into Windchill. By the way, that can be no small task. If you have very large assembly tables, if you have, broad interchange groups, just getting this kind of template infrastructure into Windchill can be a bit laborious or a little bit of a hurdle to get over because of the size of the data set. But let's assume that you've got this all into Windchill and everything's ready to go. One of the key issues here is actually generating a new configuration. And this is where we see companies struggle within a Windchill PLM environment, trying to use these traditional CAD automation tools. In my opinion, there's really only 3 ways to generate a new configuration in this environment based off this kind of template infrastructure with traditional CAD automation. The first is to simply back up your data to a new directory on your file system. And then you can go through a rename process, change values within your notebook, run the program, regenerate your Creo assembly, and then look to reload it through an import process in your workspace back into the Windchill PLM environment. The second option would be to generate and work with a very large family table at the top level. And in that case, you could, in essence, check out the top level assembly. You can even use program, and as you walk through that, one of the options on program when you execute the program is to instantiate that solution as a new family table instance, and you can certainly do that. And the third is to save as. Now those first two options, backing it up to a new directory and or generating a new family table instance, are very problematic. The first one, when you're backing it up to a new directory, it's very difficult to tell what you need to rename. Even walking through that rename process can cause issues, and getting it back into Windchill, depending on the size of your assembly, can be a little bit difficult. Generating a new family table instance at a top-level assembly level is also very problematic because, for one, that's requiring the user to check out the top-level assembly at the time of the new configuration generation, and therefore locking that assembly against other users generating a new configuration. And further, it can lead to very, very large family tables that Windchill's trying to manage. So most companies that are working in this environment would move or prefer to go to the save as approach. And this save as approach does work, and you certainly can use this, but Creo does provide a user interface, Windchill does as well, to be able to walk through and rename parts or reuse parts through this UI. But this is really, in my opinion, not a very efficient process. You'll see things like these red stoplights that occur because you're trying to rename the top-level assembly, and there's some reference there. There's also the question of, should I rename everything, or what should I be renaming? In other words, what parts are really going to be changing as I go through this new configuration definition? As we all know, every part number that you generate within a company has a cost. You have to track it, you have to understand it. Some companies, the cost is higher than others, but there is a cost there to generating new part numbers. So it's important to understand and ensure that you're only giving new part numbers to the components or the geometric definition of those components that are actually changing. So we want to be able to control that. We want to be able to make this easy. And then there's a couple other things that can occur. You have to actually be kind of careful on what you're renaming, because the model names can be directly accessed within Pro Program. And of course, if you rename a component that is in a Pro Program that is directly referenced, you're going to have problems with your Pro Program. So the potential to introduce errors through your automation is present, and you need to be aware of. And the other issue is that if you are using this notebook to Pro Program approach, you can only have, your notebooks can only have a single value. So if I have a length parameter, a depth parameter in my notebook, and it's going to change per configuration, I'm going to need another notebook. And there's references that can occur in those notebooks through the declaration process that can potentially introduce ghost objects and other issues. So all these things limit the efficiency of that CAD automation when you're in a Windchill PLM environment. So really, what is the solution? How do we still leverage potentially some of these automation tools, but we solve some of these issues that I just described? And the answer is really to build a custom configurator. And this might sound a little bit scary to people, or perhaps maybe you're on the line and your company has actually built these custom configurators. But I want to walk through why you would want to build these custom configurators, and also a solution as to how you can build these custom configurators efficiently. So the first thing that I want to bring up is, if you do go down the road of building a custom configurator, you can build out, obviously, a custom interface. And this custom interface does not have to be and shouldn't be structured or built into the Creo parametric user interface. We can build out a standalone user interface that allows an individual to input dimensional values as needed. We can build up option selections through pull-down menus or other methods to select options, maybe a graphical display of what you're actually selecting with radio buttons. We can build out selection filtering. So if I select a particular option, I might be presented less options on another selection. Maybe I select a premium solution for a car, and that only provides certain selections for the seats, being leather, black leather versus tan leather, or something like that, where we're driving the UI and we're allowing certain selections in a process of going through this UI to drive the individual to a particular solution. Many of our customers want a simplified graphical layout as well. So a 2D view, for example, of what you're actually configuring before you actually drive the 3D model, or perhaps a general arrangement drawing that you want to present back to your customer prior to the order being placed so that they can approve a quote. We also would want to be able to develop warning messages so that we understand the implications of some of the selections we have, and perhaps a modular UI that would allow us to go in and configure some high-level data about the product and then go into subsystems about what we're actually configuring and pass that subsystem information back up into the top-level configuration. And that input should also have obviously some logic behind it. So a calculation engine through standard programming, mathematical equations, table lookups, matrix solutions, new part number identifications, and the user should be able to iterate through the input and calculations engine to understand the implications that they're choosing and how that affects the overall design. And ultimately, once the user has decided on a configuration through that feedback that they're receiving, the configurator itself would be able to actually go out into the Windchill PLM environment, understand existing parts that would be utilized based on the input from the user, identify new components that need to be created. We could still leverage this template model approach by understanding what we will want to do and what template models we want to use, and automate that save as process that I was just talking about, being able to give these template models new part numbers and ultimately be able to arrive at a new solution typically from the bottom up. So we're not suppressing or resuming components from this large assembly structure that I was talking about, but ultimately developing a new assembly within the Creo environment and Windchill environment with existing part numbers and new part numbers. And for those new part numbers, we would want the configurator to ultimately build out whatever deliverables we need, from drawings to specification information and bills of materials. So from a high level, this typically sounds good for most companies. The problem is, what's the level of effort to actually go out and build this configurator? And what solution should we use to build the configurator? In the PTC product line, you could use Toolkit to do this. You could go out and start from scratch. However, using Toolkit and some of these other approaches clearly involves the need to have a certain level of programming skill to do that. And what we're trying to do at TriStar is actually to enable companies to be able to easily build these configurators and to allow individuals that are expert in the CAD tools and in Creo that may be familiar with things like ProProgram to actually build out these configurators without needing to know C++ or different programming languages to build that out. And so the solution that we have is a tool called RuleSoft. And RuleSoft at its heart is a rapid application development environment. So there's an editor environment within RuleSoft that you can see down here in the lower right that allows a user to be able to quickly build out this custom UI. I can drag in images, I can drag in input screens, I can drag in action buttons, if you will, and other functions to help build out this UI and build out those rules I was talking about with selection filtering, input screens, and a UI that drives the user through a configuration process. This RuleSoft environment can be linked to Creo, Parametric, the Creo View, and in fact to other CAD tools like SolidWorks and AutoCAD. And it's very common for companies that are using RuleSoft to actually link this to both AutoCAD and Creo Parametric in the use case I was talking about for that general arrangement drawing. So I could have the configuration process through this application of RuleSoft build a AutoCAD drawing in conjunction with a Creo Parametric model. And the way that we've linked RuleSoft into these CAD tools, into Creo Parametric, is to what I call wrap the API. So in the case of Creo Parametric, we're actually using both toolkit functions and Visual Basic functions through their API there. And that allows an individual to easily build out, again, what I call scripting. You don't need to know all the functions within the Visual Basic API to, for example, assemble a component. That could take actually about 6 to 10 lines of code just to assemble a component through the Visual Basic API. In the case of RuleSoft, it's really a single command. We just say Creo assemble and pass it the arguments of what constraints and references we're going to use to assemble that. So I would assert that if you know how to use ProProgram, you could actually use RuleSoft to generate this automation. And further, we actually have tools within RuleSoft that we can read ProPrograms and convert that logic that you have in a ProProgram to a RuleSoft script. And we can also tie RuleSoft directly into Windchill via web services. So not only do you, if you want to create CAD data, 3D data, or even 2D data with AutoCAD, but we can actually have the RuleSoft configurator, the user interface or app from RuleSoft, go directly into Windchill to build parts, to build WT part structures, to create documents, and build references between the WT parts and those documents. So there's a wide variety of functions that we can use from a single UI developed in RuleSoft to drive Windchill and Creo. And ultimately, the to-be state we're helping companies get to is to have these RuleSoft configurators on the front end. And some companies will have multiple based on their product line, based on the users. We can build out a sales configurator that the output could be a quote. We could have that sales configurator feed into an engineering configurator and have the engineer further fill out information and build out 3D models. So it's very flexible in how you want to deploy it. But ultimately, that RuleSoft configurator will be talking directly to your Windchill and Creo environment to be able to automate data generation, be able to manage that data, be able to leverage the Windchill visualization services to generate output, whether that's PDFs of drawings or lightweight 3D visualization files. And again, we can actually drive part management and BOM management from those configurators as well. This also allows us to enable and initiate Windchill workflow processes from those configurators and ultimately set up approvals and review processes, perhaps per order, to help streamline and track the order fulfillment process and pass information downstream into ERP packages. So ultimately, you're going to end up with an integrated sales and engineering environment where all that data is managed in Windchill. We can automate that data generation and therefore consolidate data sources and streamline those processes. So this is where we're trying to help companies go. We'll walk into a live demonstration at this point. And for today's example, what we're going to be showing you is a pretty simple example. We just want to show you kind of an introduction on how these tools can work. I'll be running Creo within a Windchill integrated environment. And we've built out just a fictitious electronic racks assembly. So the idea would be that this is a custom electronics rack. It would consist of different electrical equipment, maybe a power distribution unit. There is a configurable module within this rack that has different electronic components that can drop into these different slots. And ultimately, this rack could change in size. It can change height, length, width. The amount of equipment within the rack can change. And so how do we build up an environment where an end user, an engineer in this case for our example, is going to be able to quickly develop the layout of this rack, decide which equipment they're going to be using, adjust dimensions, and generate a new rack configuration. So I'll be using a RuleSoft application. I'm going to start out showing you basically how the end user could interact with this application, how it works with both Windchill and Creo, and then we'll look at the editor at the end of this demonstration and show you a little bit on the back end how this was generated.
Hey, Steve, before you jump into that, just a quick question while you're getting this set up. Just a general question, can RuleSoft be linked to ANSYS products?
It can be linked through Creo to ANSYS product, and I might want to take that question a little bit offline with Emil. I don't know if we have an email address on that, but
yes, we do. So we can definitely follow up with that.
The short answer is yes. The longer answer is how you'd want to do that.
Perfect. And I think you might have already addressed it just before you jump in again. Interchange assemblies created a lot of performance problems when retrieving from Windchill PDM link. Is there tricks to kind of prevent that with RuleSoft? sort
Well,
of a
really
general
what you'll
question.
see here is ultimately the trick with RuleSoft is we don't need an interchange assembly. And that's something that I'm going to be demonstrating.
Excellent. Okay.
Yeah, and I understand what you're saying. If you put many components into an interchange assembly and you're forced to download and bring into memory that interchange assembly um, to initiate that component replacement, you're going to, you could potentially be led into very large workspaces and potentially be led into performance problems. So I completely understand that issue. What we're trying to do with RuleSoft, and what I'll show you in this demo here in just a second, is we're trying to avoid, or we can avoid, we have the ability to avoid these very large top-level assemblies that I was talking about, and we can eliminate interchange assemblies and in fact family tables altogether. There's a couple components I'm going to show you in this demonstration that have family tables for things like connectors, which are fine in my opinion, but we want to avoid these large family tables and these large interchange groups, which is what I'll show.
Perfect. All right, go ahead.
Okay, great, thanks. So let me introduce you a little bit to the environment here. So I'm running Creo 8. We're linked into a Windchill server, one of TriStar's demonstration server on the Azure cloud. I have a workspace that I'm tied to, and right now this workspace is completely empty. So nothing is in it. And this might be how I would start my day as a mechanical engineer that's required to develop a new configuration of that rack. I have RuleSoft running, and I'm running a fairly simple application here alongside my Creo and Windchill environment. This application was launched standalone, just as an icon off my desktop. I could launch it within the Creo ribbon. So users of RuleSoft applications, kind of the use cases can vary. Maybe I'm a sales engineer and I just simply launch RuleSoft. As I mentioned earlier, I don't need to run this link to Creo. Or maybe I want to use my RuleSoft application almost as a wizard alongside my work within Creo. We could run it either way. The user interface we developed through that that editor environment, completely configurable. If you don't like the user interface, you can change it. I'm a mechanical engineer. Another guy I was working with, a mechanical engineer, so we're not interface designers. But the idea I think you'll get here. This is meant to be kind of a startup page for a new project, a project information type page. You'll notice that I have a warning message here, and if I hover over that, it's telling me, hey, before you can actually proceed, you must go search through a design and PDM link to start the project, and that's what the search button is for. We also have a couple of red X buttons here that are just warning messages that you must have some information filled out. So kind of pretty simple here. So I can start typing in some information. Who the customer contact is, not really important here. I can put in a PO number, and you can see as I start typing here, those warning messages start to go away. And now I could give this a job number. So we'll just start typing in a job number. I could have this auto-generated if I wanted to do that. It's starting to pull out what my new CAD file name is going to be based on some logic. And then I could simply hit the search button here. And what this is actually doing is it's going into my common space and searching for that particular part number. So there's a whole very different ways that you can control the searching through the Windchill environment to see if a component exists. We could drive that through the attributes that I'm filling out or through selections. We could set up an intelligent part numbering scheme and go look for that part number. So that's just kind of based on a company's requirements and how they want to do that. But you'll notice after I hit the search button here, it told me that there was no existing product or project with that criteria, and a new button appeared for me on this user interface. So this is just a quick example of how we can control the UI and also check for existing components here. So in this case, I didn't have a existing project that met those criteria, so I'm going to have my RuleSoft application here go set up a new project for me. And in essence, what this is doing is actually automating the save as process in the background. So it went in and we did have a template model from the start that is being utilized. But this template model is not a large assembly. We started here creating a new assembly at the top level for me. and I built out this new rack, and I can see what to do based on my model tree standard Windchill and Creo functionality here. And you can see it automatically renamed some of these components for this rack, and we're just starting out with a blank rack. Further, you can also see that we are actually using top-down design methodology here. So this template model that we have that we're starting from does utilize a skeleton model, and that skeleton model does have some very basic relationships to set kind of the overall size of the rack here. So that's very important. First of all, as I mentioned, automating the save as process. I didn't have to go do any manual searching. I didn't have to go through that save as dialog box. I'm not using a top level assembly here, but I am getting new part numbers, and I am using some of those top-down design techniques that I can leverage within the Creo parametric environment. So now my project is set up. Clearly now I need to adjust probably my rack size. I want to go in and add different components. So I'll go to the next page of my configurator here. And there's some very simple items up on the top here. I could set up and enter in the overall height of this particular rack. I could enter in a depth here to a certain value. I can enter in a width. And what you might have noticed here is that this is a layout view of my rack, showing me a front view and a back view, and a very simple rectangular, obviously, view, just showing me the overall dimensions of this rack. And this is, accurate. This is to scale. It's vector-based drawing here. So this is, again, not static, and it is to scale. And so I can start laying out some simple dimensions here. This is kind of the world's simplest example. But now I'm just passing a few parameters from my RuleSoft application into the Creo parametric environment. And we're simply passing that into our skeleton model and hitting regenerate. And now I've updated the size of my rack. So I don't have to be using this with Creo again. Somebody could have been using the standalone and looking at this as a preview. Or again, I could be using it tied to the Creo parametric environment. So we can set up, generate the new project. We can set the overall size of our rack. That's pretty cool. But what's more important here is adding in the electronic equipment into this rack. So we'll start by adding in some electronic modules here. And we've got a new user interface down at the bottom. That's a table that's allowing us to add in, delete, adjust new modules. And this is an example of a modular-based user interface within RuleSoft. So I'm in essence creating a new subassembly here. This is a rack modular unit. And bear with me here. So sometimes GoToMeeting does a little bit weird things on the UI. But what this allows me to do, and what you'll see here, is this new rack module has been added into my layout as a preview here. And I have a user interface over on the left here to start configuring this electronics module. And in the case of this example, there's about 18 different slots for different electronic components that can go into these different slots. And in this case, I can just select different electronic equipments to pop in. And this is giving me a preview of this. This is not 3D CAD data that's dropping in here. This is just actually images that we're pulling into this preview, both on this modular base level here, as well as in the top level layout view, and getting a look at the front view and the back view of this different items that we're driving in. This could have been read in from a spreadsheet, maybe out of sales spreadsheet or something like that. We could have put an input screen in that says read in all the different components that need to be in each slot, or we could have a simple pull down right here. But the idea is the ability to give you kind of a preview of what it looks like, allow the user to go through the selection, and most importantly, an example of this modular-based UI. We could have in different mounting mechanisms for this unit within the rack. Maybe one goes on a slide, or there's a fixed mounting bracket. I can adjust the location here. So maybe I want this 12 inches off the ground. And you can see there that this module moved within the top level. Now I could go in and create the module as a subassembly at this point, or I might say, hey, I'm done at this point. I want to go configure a new module within my rack. Maybe I need a couple different modules here. So I'll add in another one. It adds into the table, so it's keeping track of these different modules that we're creating, these different electronic units. And I won't spend much time here, but we could just add in a couple of these different electronic sensing subassemblies. making a couple selections here, and maybe that's good. But perhaps this rack I want, or this unit I want at a different position in my rack. I'll move it up to 24 inches. And that's looking pretty good there. But maybe, you know, the height of this overall rack now is looking like it's a little bit too tall. So I'll adjust that to 40 inches. And now I can see again in this preview, it's a little bit more evident when I now have some modules in here, and I can now see the overall size of my rack. So I could finish this off here, and maybe again, I'm a user using the standalone, and another engineer could pick that up and regenerate it. Or I could say, hey, let's go into Creo and actually make those changes. Now this does take just a second here to go make these changes, but what's actually occurring in the background is we're going out and creating these new monitor assemblies from the bottom up. And you can see that monitor assembly popping into my model tree over there on the left. The bracing is being brought into my assembly and actually adjusting the size, because the mounting brackets are dependent on some of the frame dimensions here. And we're also, you know, downloading some of the existing components that need to be in my rack assembly. Those are existing components within the Windchill environment, and adding those into my workspace, and now generating this new assembly that has the mounting brackets adjusted to the appropriate size. It has the new rack modules with the appropriate equipment that's set up and assembled. And if I go look at this, one of these monitor assemblies here, again, this was a brand new assembly. We didn't use any family tables. We did not use any interchange group. What was going on here is that we have a new assembly that was being created, and we pulled in these sub-assemblies here for the sensing equipment and assembled them using standard constraints. If I choose to edit the definition of here, you can see just some standard constraints here for how this was assembled. So, you know, for the question about you know, using interchange assemblies and family tables, that's one of the things that we're avoiding here by limiting this reference chain, by building from the bottom up, and by automating the save as process. We're really building some efficiencies here and allowing the individual end user to work in this Windchill PLM environment without the typical consequences, if you will. Now I could continue to add more components into this rack. So maybe I want a power distribution unit. In this case, when we hit these different buttons, we're adjusting the user interface down here. And again, what we're trying to do is show you an example of how we can build out this configurable UI. But this is all set up, you know, by default for you. What you can see here is it's added in this rack right now at a certain height value. Maybe I want to bring this down to 2 inches, and I can get a look at how that looks. You can see it dynamically updating in my 3D environment. In this case, maybe that's where I want my power distribution unit, but now I have another issue where I have an interface here. That interface, or I'm sorry, interference. The interference is being shown in my 3D model. Not so prevalent in my preview because I don't have all the detail, although we could have it there. But I could adjust this very quickly. I could go back to my rack module, and maybe now what I could do is adjust the positional value of where that bottom rack is. Maybe I'll just push this up you know, to 15 inches or something of that nature, and I can see that move. And I'm done there. That looks all right. Maybe in this case, I'll update the position of that other unit. So we'll pull up that other unit's configuration here. And I could say, all right, this guy, maybe we'll push this up to 26 inches, and that'll add some position there for that one. Maybe I recognize that as I look at this rack here, it's got a little bit too much depth. Now this is an interesting one where if I adjust this down to 18 inches, I need to adjust the size of those braces here. So I'll change that depth, and when I'm done, I'll just go ahead and hit the regenerate button again, and I'm passing all this information from my configurator and from that preview back into my environment, my CAD environment here, and I have this updated assembly. You can see that a lot of things happen there. We've of course got that power distribution unit, the power supply added into my assembly. We've repositioned those racks or those units. We've adjusted the overall size of my rack, and due to the change in the depth, we've actually changed the overall size of those braces that are occurring in this environment. So a lot of, even in this real simple example, there's a lot of powerful things going on here. We don't have a layout that we're working with, so therefore I don't have this long reference chain. We're not using family tables here other than a couple of different connectors that are here in our library. And we're automating that save as process is occurring. So I can build out a user interface here that, we could completely build this rack up. I can have optional choices in here to add fans and wireways, whatever components we need. We can include cabling in here. So we can do a lot of automated tasks within the RuleSoft application to pass that information into Creo Parametric. Or as an end user, I might just use this as a front end to automate that save as process, get me 80–90% of the way there. And then if I'm done with this, I just simply hit done. And now I'm working in the environment of just like I started from scratch in this Creo environment. And I could, of course, assemble components in here. I could redefine, I could actually change the dimensions of this skeleton. I could do whatever I need to be able to continue my design here. Right? In this case, I'm just simply going to save this object, this assembly. If I go back and look at my workspace, what you'll notice now is I have about 50 components in my workspace. I don't have a large interchange assembly in here. I didn't blow my workspace out with hundreds of instances. If I look at what's in my workspace here, there's a number of new items. I could, of course, filter this down to a featured object list, and this ended up generating roughly 10 new components here. We have a new top-level assembly, a new skeleton model that's helping me drive the dimensions of that rack. So I'm still, again, using standard top-down techniques within Creo Parametric. I have some of the new braces within the frame. I have the side braces for the units, and then I have the new monitor assemblies that are being generated. So we were very controlled through the logic and the configurator, what actually was changing, what needed to be generated with new part numbers, and it was very easy for the end user. At this point, I could have automated the check-in process through the RuleSoft application, or I could just simply check it in as an end user here. But I'm going to be assured that as I check this in, I am not going to have any issues like ghost objects. I'm not going to have references missing. I'm not going to have conflicts here because we have controlled the whole file renaming save as process through the configurator. So now I've checked in that object, and I'll have, if I go into my Windchill environment here in a web browser and I refresh, I will see those new objects that I've checked in. Here's my monitor assembly. Here's that new rack that I just generated right here. It's going through the publisher right now. But of course, if I go and look at that structure, I will see the CAD structure that I generated. Once the publishing is complete, I would see these new items for the frame members and the system braces. And if I look at related objects, I'm going to see a very, very limited reference scope, if you will, a limited reference chain, which is what I want to be able to control and manage this configuration going forward. So hopefully that looks impressive to you guys. I think, I would encourage people to go out and generate these custom configurators if they're in this environment where you're trying to control your configurations through Windchill PLM. You're trying to limit and gain efficiencies for your end CAD engineers. But again, the question is, how did I generate that configurator? And the way we generated this was through this RuleSoft editor. This is the RuleSoft editor environment that I'm pulling up right now. This is meant for, probably just a couple of individuals within an organization. So not every user is typically going to be generating these configurators, but we work with companies and we would, teach you to fish. We can train certainly expert users in Creo Parametric very, very quickly on how they can build out these user interfaces and how they can make changes to this user interface. What you'll see across the top are some pull-down menus where we can generate new input selections just drag and drop where I want that input selection. There we go. I could drag and drop in these warning messages. You can see one here. I can drag and drop in what we call an action button here. I can go pull off images from my hard drive. So if I want just a simple JPEG in here, or if I want to even go do some different design, I can drop in text as a label right here. So it's very easy to drop that in. These labels all have, obviously fonts to them that I can adjust, or what it actually says very quickly. And what you'll see over here on the right-hand side these are the properties of these different items. We call them controls that we're dropping into our user interface. In the case of an action button, I can right-click over in here and say, let me edit the actual script here. And this is a Visual Basic type of script editor here, where I can drop in what function is going to be. And this is where I asserted earlier, where if you know how to do program, you would be able to learn this scripting language very quickly. There's help in here. If I start typing in CAD dot, what you'll see is these are all the functions that I could go call into Creo. So if I wanted to say at a certain point in my script to go regenerate my model, I could simply hit the regenerate function, and that's where it's going to go out and build that and regenerate that call. So it's very quick and easy to build out these scripts. Of course, they can be complicated, but that's the power here. If I go look at some functions like a subroutine or something that we can develop, there are, like create this module. This is actually a subroutine here. I could go run this as an individual script, and what you'll see is we're pulling in some information about what to use the top level assembly name. That's just pulling into dimensional value. And we're walking through and we're regenerating and aligning components. So here's the assembly constraints. We're going to do an align and align and add that component in. And we're basically going to loop through that for each one of those components as we walk through those steps. So it's really a straightforward scripting language. As I mentioned earlier, we can read in existing programs into that scripting environment and go through basically a cleansing routine to be able to improve and convert a program environment into a RuleSoft environment. And of course, we could build out this UI to whatever your needs say fit. We can drop in Creo view as well. I showed you an example of 2D sketching, but we can actually have a Creo view window in this environment as well, where the user just in the RuleSoft application can actually get a look at the 3D environment. We can drop in, table functions and all sorts of different items to build out a UI that helps you drive through those configurations. So hopefully that gave you an idea of where you can go with some of these CAD automation tools. Again, I understand the power behind some of the traditional Creo parametric automation tools, the tools that we were talking about, Notebook, Program, and interchange groups and family tables. Even the top-down design tools of using skeleton models and data sharing features. What we're trying to do with the RuleSoft environment is to enhance those tools, to break down some of those barriers that we see companies traditionally struggle with. Specifically things like the save as function and configuration management, as well as to be able to take that next step in user efficiency through things like, again, streamlining the UI, streamlining that save as process, adding more functionality into what you can do in automation. So I want to thank everybody for joining our webinar. You can find out more information about TriStar at our webpage, tristar.com. If you go up to tristar.com and look at solutions under automation, you can find out information about RuleSoft. You can contact us directly and we can go into a more detailed demonstration. We're also available to look at your specific application and have a discussion on how that could fit in. And with that, I will wrap up and Adam, see if there's any additional questions that might have occurred in the queue.
Yeah, so we'll just hold for a moment. And to reiterate what Steve mentioned, we do have some additional brochures. This was kind of just the tip of the iceberg as far as what RuleSoft can do. So there is some good webinars on just the different functionality, different configurations that are possible with RuleSoft. So definitely check it out. And I did want to finally mention everyone who registered, they're going to get a copy of this webinar so you can kind of take a look on your own time. Definitely, feel free to share with colleagues on social media. Very powerful tool as Steve just demonstrated. And it doesn't appear that we have any further questions. So again, Steve, that was excellent. Definitely appreciate you taking the time to do that. And thank you everyone for joining us today.
Thanks, everyone. I appreciate your time.
All right. Have a great day. Enjoy the rest of your Thursday and enjoy your Friday and your weekend, everyone. Thank you.